Okay, so what I'm going to do now is make a new plate. This time I'm going to make the plate so that it is 8 columns wide. And when I make a new plate, we have to get rid of the old plate. Now, that's something I could change. I just find it's less confusing to the students if they only have to deal with one plate at a time. So this time, what we're going to be doing is measuring the enzyme activity. And the way that that's done in the prac is that you make a little dilution of the enzyme, 1 ml of enzyme, 1 ml of buffer, and you make a substrate solution, which is a 1 in 4 dilution of the stock substrate, and you make 4 mils of that. And to get things going, you add half a mil of the diluted enzyme to the 4 mils of the substrate and take half mil samples every minute or 5 or whatever. So as before, stopping the reaction is a 1 in 10 dilution. So again, I'm going to do it by putting 20 microliters of the mixture, the reaction mixture, into 180 of sodium hydroxide. So I'll have the sodium hydroxide waiting in these wells here. So let's put 180 microliters of sodium hydroxide into each of these wells. These are going to be where the reaction stops, and these are basically the equivalent of tubes 1 to 8 or whatever they were in the normal prac notes. So this is not only going to be the stopping, it's also going to be a one-stop shop for measuring the absorbance as well. So during the reaction, as soon as we've added the enzyme to the substrate, we're only going to be taking 20 microliters each time. So we actually only need to do the reaction in about 200, 300 microliters of solution. So instead of doing these mil quantities here, I'm going to scale everything down by 10. I'm going to dilute the enzyme 100 of buffer, 100 of enzyme, and I'm going to make the substrate mixture 100 of the substrate and 300 of buffer. And I'm going to start the reaction by putting 100 of tube A into tube B. So let's make those two tubes. Whoops, let's not do it that way. Let's make a rack where we've got 2 tubes and 2 columns and 1 row for a rack. And that's our rack. I can change the temperature of this rack to whatever I want. In fact, I will make it 30 degrees because that's what we want it to be. So this rack's now at 30. Actually, it doesn't show up very well on the gold bench. Perhaps not all the benches at Wollongong are gold. We could change the colour of the bench, I'm sure, to say this sort of bluey colour. That might be quite nice. Now, what I'm going to do then is put 100 microliters of enzyme and 100 microliters of buffer into this tube here. So let's get our pipette and do 100 microliters of enzyme and a new tip and open the lid of the buffer and 100 microliters of buffer. So let's give that a mix. Always very, very important to mix. Close the enzyme. Always important to close the tubes that you're not using. There's a trap for young players. Now I'm going to make the dilution of the substrate. So I've got the nitrophenol phosphate, 100 microliters in there. And let's make a new tip. Actually, it's going to be a 300 microliter addition, isn't it, of the buffer. So we'll use a P1000. And we've got that in there, and we'll give it a good mix. So this is the reaction tube here. Tube number 8 is the reaction. Tube number 7 is the enzyme. So let's get the timer ready up in the top right hand corner. Let's get our 100 microliters of stuff ready to add. So new tip, open this one up, suck up. This is the enzyme buffer. Put into here, start the clock, get rid of the enzyme, give it a mix, and whoops, give it a mix, And now, after we've been going for 10 seconds, let's get our P20 out and take up a sample and put it in the first one. And that's actually a 20-second sample. So we'll just remember that that was 20 seconds. Then we'll get a new pipette tip and we'll do the next sample at 1 minute. Now, just to make things go a little bit faster, I'm going to increase the speed dilation in a second. But first of all, I'll get this 1 minute sample done nice and accurately. So 10 seconds to go. I like to take it about 5 seconds before it actually hits. So by the time it actually enters the hydroxide, it should be exactly 1 minute. And it's already got a bit of a tinge, hasn't it? So let's just crank up the speed a little bit so that we're going a little bit faster so that we don't have to hang around too long. So make that my pipette tip and we'll do a 2 minute sample, taking that up and putting it in. So it's slightly over. You can see though we've got some yellow colour definitely forming a bit faster than I was expecting actually. So let's take a sample now. Well, it's been gone 3 minutes. Let's do one at 4 minutes. So I'm going to pull up the sample and pop it in. That was a 4 minute sample. Yeah, it's it's going quite fast. You know what? I think this is going to be a slightly more active enzyme than what's in the prep, but that's easily solved, isn't it? That's actually a challenge in its own right. So we've got another one here. Let's do this at 6 minutes. And then I think we might call it a day because it's already looking extremely yellow. So we'll take the speed back down. Now you can actually take the speed to 0, which freezes time, but that's silly. Still got this set to 400. Let's have a look at our absorbances. Well, I suppose we should mix first, shouldn't we? That would be sensible. Check the absorbances, and you can see here that we've got this nice time course. I'll just go back to our Excel spreadsheet. This time that was 20 seconds, that was a minute, that was 2 minutes. You can see it's doubled, and then it went up. You know, it's almost doubled again. I think that was near 4 minutes, wasn't it? And then that's 6 minutes. So it's a really nice, steady looking time course. We would probably want to dilute that enzyme to get it so that it's a little bit more manageable in terms of the time. But regardless, we have done the experiment in just a few minutes. Loads for the students to play with there. Lots, different enzyme dilutions. Obviously, they'll do different substrate concentrations later on when they're establishing the Km and the Vmax. Over really, really quickly, but so much to play with and so many options for assessment because, of course, these numbers are going to be completely different for every student, but they are uniquely identified for every student by this run number because that only ever happens once in the lifetime. So that's where we are, and hopefully that will give you some ideas for where you could take this.